These beautiful disco patterns are a result of diffraction of light caused by an optical arrangement known as grating. Interference patterns we saw earlier were the result of one or two narrow slits. A large number of parallel, closely spaced slits constitutes a diffraction grating. Put simply, a large collection of very small slits. The condition for maximum intensity is the same as that of double slit or multiple slits. But with a large number of slits, the intensity maximum is very sharp and narrow. When huge slits are present in the same area, we get a sharp maxima and minima. With the help of a formula, let us find the width between two slits placed very close to each other. Cheapest grating available for this activity is the CD or DVD, which are now very old-fashioned. I will cover the details of preparing a CD as a grating tool later. Let us take 2-feet ruler and attach a red laser upside down with the help of rubber bands. Ruler is placed on the water bottles acting as a stand. When the CD is placed right below the pointer, light gets reflected. Instead of just one point, we see two more points. This is because of the diffraction of light caused by the gratings on the CD. With the observed pattern, can we find out the width between two slits? Equation which correlates these findings is as follows. D sin theta is equal to m lambda, where d is the distance between slit, lambda is the wavelength of light, theta is the angle of diffraction, and m is the order number. We can take readings at different values of d as well. Let us find out the value of theta first. X is the first order distance while d is the distance of the slit from the screen. In our case, ruler. Theta, angle of diffraction, can be found out by calculating tan inverse. Small d, distance between two slits, can be calculated with the help of this formula. Lambda is the wavelength of red light, which is 650 nanometer in our case. With all the values in the equation, we get a value of 1.44 microns or micrometers. As per the specification, it is 1.6 micrometer. Given the homely setup, we are okay for now. How about replacing CD with DVD? Will the readings differ? Yes, DVD can store more information in the same total area. Tracks are closely spaced. Repeating the same calculations for the DVD setup gives us the track separation distance as 0.73 micron, which is very close to the specification value of 0.74 microns. We calculated the width between two tracks by reflecting light off the CD. There is another method, transmission grating. Reflective coating can be peeled off with the help of a sticky tape, and we have a transmission grating from the CD. This time, we will pass the laser light through the CD and observe the maxima on the other side. Same setup can be tried with the plain diffraction grating as well. Replacing data in the formula gives identical result for transmission grating as well. Here is what I could calculate based on the experimental finding. What will happen if I replace the red light with the green one? Wavelength of green light is 100 nanometer less than that of the red one. That is 550 nanometer. Will there be any change in the value of x, the distance for the first maxima? As per the formula, wavelength decreases, angle also decreases for the same distance between slits. First maxima will be closer to the center. How about the orientation of the slit? I can rotate this small piece of disc and you can see the effect yourself. Do try this yourself and find out the slit width for other types of gratings like this Blu-ray DVD. You can also use an online calculator on Hyperphysics website as well. Diffraction gratings are used when there is a need to separate light of different wavelengths with high resolution. Let us use flashlight from our phone. Nice rainbow colors are seen when it is passed through a prism, but colors are very closely spaced. When passed through the grating, separation is very clear. I thought computer hard disk will also have gratings like CD or DVD. I was wrong. Storage on these disks is in magnetic form. Do try this at home. Thank you.